It seems like time is running out for the Hubble Telescope after it recently shut down, and SpaceX may be NASA's only hope to save the iconic space observatory. But does SpaceX have the capability to attempt an ambitious rescue mission for the telescope? Let's take a look at the Hubble Telescope's importance and troubled past and how SpaceX could be NASA's only hope at attempting to salvage the historic craft. 30 years ago, our gaze turned toward the cosmos, and the Hubble Space Telescope played a pivotal role in bringing the universe into sharp focus. Over the years, it has unveiled the birth of galaxies, witnessed the demise of stars, and peered deep into the vastness of time. However, Hubble's journey wasn't always smooth. It had a rocky and initially blurry start, becoming the subject of ridicule. Throughout history, humans have sought to comprehend the celestial wonders above, with the night sky and the Milky Way prompting millennia of contemplation. Galileo's invention of the telescope allowed us to explore the heavens from our earthly vantage point, offering a glimpse into the cosmic mysteries. Little did Galileo anticipate the advancements that the space age would usher in. With the advent of space exploration, the possibilities expanded. A large space telescope orbiting above Earth could overcome the distortions caused by our planet's atmosphere, offering unparalleled clarity. Unlike ground-based telescopes, which grapple with atmospheric turbulence, a space-based telescope's resolution is primarily limited by mirror diffraction. Moreover, it can operate continuously without being hindered by weather conditions, providing an uninterrupted view of the cosmos. The advantages of a space telescope extend to its ability to access the entire electromagnetic spectrum. Earth's atmosphere obstructs various wavelengths, including infrared, ultraviolet, gamma rays, and X-rays. In contrast, space observatories can explore these hidden realms, offering scientists a broader understanding of the universe. Scientists eagerly anticipated discovering the invisible facets of the cosmos, and the space telescope exceeded expectations. Unveiling a wealth of previously unseen phenomena, it demonstrated the vast potential of observing the universe beyond the limits of the naked eye. The early orbiting observatories such as OAO2, Uhuru, and IRIS provided glimpses into an unseen universe, inspiring NASA to initiate the Space Telescope program in the late 1970s. Congress approved and funded this program, and the European Space Agency collaborated to circumvent budget constraints. Construction began in the late 1970s for what would become the Hubble Space Telescope. This groundbreaking telescope, equipped with a 94-inch mirror comparable to the one on the Hooker Telescope in Mount Wilson, California, was designed for launch and servicing by the developing space shuttle. Mount Wilson and the Hooker Telescope are noteworthy because astronomer Edwin Hubble utilized them to confirm the existence of galaxies and expand our understanding of the vastness of the universe beyond the Milky Way. His observations, particularly of what was then called the Andromeda Nebula, now known as the Andromeda Galaxy, laid the foundation for our comprehension of the cosmos. In tribute to Edwin Hubble, the Space Telescope was named after him in 1983. Originally slated for launch in 1983, setbacks with the contractor pushed the Hubble's launch to late 1986. However, the telescope was completed and almost ready for transportation through the Panama Canal to the Kennedy Space Center when the Space Shuttle Challenger tragedy occurred in January 1986. The launch date was further delayed to spring 1990 as upgrades were implemented to enhance shuttle safety. Finally, on April 24, 1990, during the STS-31 mission, the Space Shuttle Discovery successfully deployed the Hubble Space Telescope approximately 380 miles above Earth. Nevertheless, a significant issue emerged with the Hubble Space Telescope, deeply embedded in its primary mirror. This minute flaw, smaller than 1/150th the size of a human hair, surfaced as flight controllers at the Goddard Space Flight Center endeavored to focus the telescope. The problem, identified as spherical aberration, rendered Hubble nearsighted because the mirror had been ground to an incorrect shape. Consequently, rays of light entering the telescope failed to converge on a single focal point. Although the telescope could still conduct scientific observations, it lacked the anticipated diffraction-limited performance crucial for groundbreaking research. Fortunately, a remedy existed: contact lenses of sorts. Corrective optics could rectify Hubble's vision, restoring it to the promised performance astronomers eagerly anticipated. The key to this solution lay in the Space Shuttle, which had resumed regular flights. Hubble had been designed for on-orbit servicing, and a servicing mission was already scheduled for 1993 as part of a routine service maintenance every 3 years. The 1993 mission assumed immense importance for NASA's future. particularly in light of the challenges the agency faced in the early 1990s. These challenges ranged from post-Cold War budget cuts, jeopardizing the space station Freedom, now the ISS, to setbacks in other programs, such as the Mars Observer mission, which encountered propulsion issues just before entering Mars's orbit. On December 2, 1993, Space Shuttle Endeavour, one of NASA's most reliable shuttles, lifted off from Pad 39B at the Kennedy Space Center, carrying 7 astronauts and an array of repair equipment and instruments. The STS-61 crew embarked on a mission to correct Hubble's vision. These seasoned astronauts, veterans of previous spaceflights, underwent cross-training to handle each other's tasks as they prepared for a remarkable 5 consecutive extravehicular activities, EVAs, or spacewalks over 5 days, setting a record at that time. During the servicing mission, astronauts worked in pairs, taking turns on different days. Meanwhile, a third mission specialist remained inside, assisting with the movement of parts and people using the Canadian-built robotic arm. However, before any repairs could commence, Endeavour had to reach Hubble and grapple the ailing spacecraft. Beyond the well-known optical flaw, Hubble faced pointing issues and solar panel jitter when transitioning between day and night due to temperature fluctuations. While not as widely publicized as the spherical aberration, these pointing issues and jitter, along with problems with the gyroscopes, were equally mission-critical. To address these issues, the first extravehicular activity, EVA, focused on installing new gyroscopes, and the second involved replacing the solar panels. On December 4th, Hubble was lowered onto the Flight Servicing Station, which had made its debut during the Solar Max repair mission in 1984. The EVA crews prepared to undertake their tasks, noting a kink in one of the solar panels. The primary objective was to provide Hubble with 6 healthy gyros for precise aiming, achieved during the 7-hour, 50-minute-long spacewalk, a duration that marked the second longest NASA spacewalk at that time. Following the gyro replacement, attention turned to the solar panels. The goal was to replace them with new ones, featuring insulation on the deployment guides to minimize the jitter caused by temperature variations. However, a kink in one of the arrays complicated matters. While attempting to retract the old solar panels for return to Earth, one panel successfully retracted, but the kinked one resisted. In response, during the EVA, astronaut Catherine Thornton discarded the damaged solar array into space, where it would eventually burn up in Earth's atmosphere. With the solar panel situation addressed, the focus shifted to optical repairs, introducing 2 new instruments. The first instrument to be installed was the Wide Field and Planetary Camera 2, a grand piano-sized device equipped with its own corrective optics, designed to replace the original instrument. Following the installation of the Wide Field and Planetary Camera 2, the astronauts proceeded to replace an old photometer with the COSTAR instrument. This new device featured 2 corrected mirrors for each of the 3 axial instruments. Each mirror was mounted on a small robotic arm, directing corrected light to its designated instrument. The successful installation of COSTAR replaced the high-speed photometer and included an upgrade to the telescope's DF224 computer system. The upgrade involved additional memory and an Intel 80386 coprocessor with an impressive clock speed of 16 MHz. The final spacewalk focused on replacing a solar array drive and constructing covers for Hubble's magnetometers. These covers were essential to prevent debris from compromising Hubble's newly improved vision. Throughout these 5 days, the crew dedicated a total of 352 hours outside Endeavour, tirelessly working on Hubble's enhancements. On December 10th, the Hubble Space Telescope was redeployed, marking a pivotal moment. The success of the extensive repair and upgrade work was now put to the test. As we know, the result is evident in the remarkable, sharp, and in-focus imagery that Hubble has continued to capture, providing invaluable insights into the universe, images that we have been fortunate to witness until now. Recently, concerns have arisen once more regarding the functionality of the Hubble Space Telescope, leading to discussions within NASA about the possibility of approving a private mission to revive and potentially repair the spacecraft. The catalyst for these discussions occurred on November 29th when NASA announced that the Hubble Space Telescope had entered safe mode due to a malfunction in one of its 3 operational gyroscopes. This particular gyroscope had previously triggered a safe mode on November 19th due to inaccurate readings. Although spacecraft controllers successfully restored Hubble's operations, issues resurfaced on November 21st and the 23rd. Currently, engineers are actively investigating the problem, and it remains uncertain when normal scientific operations will resume. While the Hubble Space Telescope can still function with just 1 gyroscope, there might be a partial loss of efficiency, especially in certain solar system observations. Originally equipped with 6 gyros during its last servicing mission in 2009, the telescope has encountered problems with 3 of these gyros malfunctioning over time. The recent temporary setback for Hubble prompted a response from Jared Isaacman, the billionaire supporter of SpaceX's Polaris program for private astronaut missions. On social media, he posted, "Put us in, coach," referring to a study announced in September 2022. This study, involving Isaacman, SpaceX, and NASA, explored the potential for a private mission utilizing SpaceX's Crew Dragon to reboot and potentially repair Hubble. Isaacman had previously suggested that a Hubble mission could be the second of 3 planned Polaris missions. The study, conducted under an unfunded Space Act agreement, concluded earlier this year, but both NASA and SpaceX have maintained confidentiality regarding the specifics of the findings and subsequent steps. Jared Isaacman, a key figure in SpaceX's Polaris program, hinted on social media that the study suggested the feasibility of a reboot and servicing mission. He stated, "This should be an easy risk-reward decision, without divulging detailed mission approaches." Although SpaceX is considered an option for servicing Hubble, NASA previously issued a request for information, seeking concepts for commercial missions to enhance the telescope's capabilities. Among the 8 responses received was one from Astroscale in collaboration with Momentus. However, NASA has not disclosed a timeline for evaluating these proposals. As part of the assessment process, NASA is closely scrutinizing the capabilities of the Hubble Space Telescope and ensuring its safety during potential servicing activities. Mark Clampin, director of NASA's Astrophysics Division, provided insights into the ongoing review of these servicing proposals during a NASA Science Town Hall meeting on July 27th. Industry insiders expressed confidence in the feasibility of a reboot mission utilizing either Crew Dragon or a robotic spacecraft. Such a mission could counteract the gradual orbital decay experienced by Hubble due to atmospheric drag, effectively prolonging its operational lifespan. However, skepticism lingers regarding the prospect of conducting repairs on Hubble, given the complexities involved in such tasks. Crew Dragon lacks essential capabilities like an airlock and a robotic arm, which are crucial for servicing missions. Additionally, existing robotic systems have not yet demonstrated their ability to execute sophisticated repairs in a challenging space environment. So what do you think? Does SpaceX have the capability to mount a rescue mission for the Hubble on short notice? Please share your thoughts in the comments below.